Yo guys, it's 3 p.m. right now, and I decided since we've recorded the bio P2 papers, might as well go over chemistry P2 papers. Also, you guys are going to notice a lot of cuts in this video, and it's mainly because I was fasting and it's hitting me really hard. But anyways, hope you guys learned something new.
Let's start off with question number 1. Here we have substance M, which is solid at 30 degrees Celsius. So this is going to be approximately 30 degrees. So right over here, this thing is a solid. The substance is heated to 80 and temperature measured as it cools down, between which times is substance M freezing. Now usually in a cooling curve, we have the gas/liquid at the top, and as it cools down, it turns into a solid. So you can see that this is the point where it actually becomes solid. The point before it turns into solid would be the point QR, where this is solid/liquid in nature. Why? Because in solid/liquid, we will see a constant temperature. And the reason is because the energy is given out by the substance M so that the bonds can form. Because usually when the energy is given out, you are losing kinetic energy, but over here we're not losing kinetic energy. We are actually giving out the energy to form bonds. Over here, however, this would most likely be liquid in nature. This is why when the temperature is decreasing, there is no change in its state, because the energy is being given out to reduce the kinetic energy. That is why their temperature decreases. And then we have phase QR, where the liquid actually starts turning into solid. So this point over here, this is going to be the melting point or the freezing point, because after this becomes a solid. And again, I explained why this should be constant, so it should just be Q2R. The equation for thermal decomposition of sodium hydrogen carbonate is shown, and here we have MRs. In an experiment, we have 2.1 grams of sodium hydrogen carbonate, but not all of it decomposes. All of the carbon dioxide is collected and measured at room temperature and pressure. The total volume of carbon dioxide collected is 0.21. What statement is correct? The mass of sodium carbonate produces 0.93. Now over here, we can clearly see that in 2.9 was the maximum amount of sodium hydrogen carbonate used, but not all of it decomposes. So how do we know how much of it actually decomposes? We need to actually use the volume of carbon dioxide to calculate the moles of carbon dioxide. And the reason is because the amount of sodium hydrogen carbonate that actually decomposes turns into carbon dioxide, like completely all of it. So how much turned into it? So let's calculate the moles of carbon dioxide, which is going to be moles is equal to volume over 24 dm cubed. We have volume, which is 0.21 divided by 24. This is going to be the moles of carbon dioxide. Now that we have the moles of the carbon dioxide, we can find the moles of the other things as well. For example, mass of sodium carbonate produces 0.93. Let's fact check this. Here we have sodium carbonate. So the moles of sodium carbonate would be, first we find the ratio. Carbon dioxide has a ratio of 1:1 with Na2CO3. Why? Because we can see over here this is 1 mole and also this is 1 mole. Anyway, so we can see that the moles of carbon dioxide should be equal to the moles of sodium carbonate. So we can see that the moles of sodium carbonate also becomes 0.00875. This is Na2CO3. Now that we have this, we can calculate the mass of sodium carbonate. How? We know that the formula for this is N is equal to grams over MR. So grams is equal to, or mass is equal to, the moles times the MR. Moles is 0.00875, and the mass is given over here, 106. So the answer that I'm getting for the mass in grams is 0.9275, which you can like clearly round this off to 0.93 grams. So the answer should just be A. Which method produces the salt copper carbonate? So this is a question in regards to acid, bases, salts, whatnot. Copper carbonate. So to form copper carbonate, you can clearly see that we will need a copper component, which is metallic in nature, and we will need a carbonate component, which is non-metallic in nature. Add copper oxide to water, then add excess sodium carbonate, filter off the precipitate. Now the first thing that we need to keep in mind is copper carbonate soluble in water or no? This is insoluble because of the solubility rules, which states that every carbonate is insoluble. However, we do have exceptions like sodium, potassium, ammonium. These guys are usually soluble in nature. So what was the rule for producing an insoluble salt? We need to mix a soluble salt with another soluble salt. So basically from these options, we need to see which salt is actually soluble in nature. Is copper oxide soluble? Is sodium carbonate soluble? Sodium carbonate is soluble, copper oxide is not soluble. We have the next option, which is add copper oxide to dilute sulfuric acid. So this is going to be a base which reacts with an acid. So this should form copper sulfate. And copper sulfate is going to be soluble because sulfates are usually soluble except barium, lead, metals like those. So this looks like the answer. Next we have add copper to dilute hydrochloric acid. Now copper, silver, gold, these three metals, they do not react with acid. You need to keep that in mind for chemistry. So we call these as CSG metals, okay? They're not going to react with acid, so there's no point. Then we add copper oxide to aqueous sodium carbonate, filter off the precipitate. Now this is also going to be wrong because copper oxide is not soluble. Okay, next up we have question 31. Which statement describes CH bonds and methane gas? And how do they contribute to global warming? So let me just show this to you guys real quick. We're going to have the sun over here. We're going to have the earth over here. Let's say this is the greenhouse gas, this yellow highlighted greenhouse gas, okay? So what's gonna happen? The sun rays are gonna penetrate to the atmosphere, they're gonna go to the earth. So when it does that, the earth is actually gonna reflect off thermal energy into the space. And instead of going to the space, actually some of it does go to space, but most of it remains trapped and it gets reflected back off into earth, which causes the global warming effect. So we can see that they absorb thermal energy from the earth. It's gonna be the earth because again, we're talking about this stage over here, this part. We are not talking about this part. So we can see that it reflects off the earth, and does it emit all of the energy towards the earth, or does it emit some of this energy? So we can see that some of this energy actually escapes into the space and some of it is going to the earth. So the option is going to be D. What is the structure of the product of the reaction of propene with bromine? What is propene? It's going to be an alkene, 3 carbons, 1, 2, 3. So what's going to be the product? So when an alkene reacts with bromine, that's going to result in an addition reaction where the bromine is going to break and intercept the double bond, and we can see that this would usually end up over here. And when it does that, the double bond gets removed because this is an addition reaction. So most likely we could see, what can we see? This option looks viable because again, these bromine atoms are within the first 2 carbons or the last 2, however you guys interpret it. So you can see that this is bonded to the bromine over here and this is bonded to it over here. What's happening over here, this is not the case because in addition reactions, the double bond breaks. There are 2 bromine molecules, so this is wrong. And we can see over here that this is too far apart. This is on the first carbon and this is on the third carbon. There should be in the first and the second carbon, respectively. Next up, we have question 38. A part of the structure of the polymer is shown. So which statements about the polymer are correct? So over here, we have 3 options. The polymer is nylon. The polymer is formed by condensation and there are ester linkages. Let's go over each option. Nylon essentially consists of a dicarboxylic acid and a diamine. So that would look something like this. You would have COOH bonds on both ends for the dicarboxylic, and you would have NH2 bonds on either end. So what do we see over here? We're going to see that if it is actually nylon, these monomers should have either C double bond O on either side or NH2 bonds on either side, which is not true. We can see there is one NH on one side and one CO on the other, which does not like match with these descriptions, so it's not one. Next, the polymer is formed by condensation. This is going to be correct. So let me give you guys a tip for condensation. Just remember, if you see these boxes, it's just condensation, okay? You don't need to waste your time, but let me just explain this to you in another way. Condensation polymerization essentially involves more than one type of monomer, okay? So we can see over here that this is a different monomer, this is a different monomer, this is a different monomer. Why? Because their boxes are different in shape and color. So, I mean, the shape is the same, another color. So this is why condensation polymer will exist over here. And also, if you can see, condensation polymerization essentially involves the loss of a small molecule like water. So this OH is going to react with one of the H from the amine group, and this will lead to the loss of water, forming that Chon linkage that you can see over here. This is the CHON Chon linkage that I say. Okay, then there are ester linkages between the monomers. No, because this is a typical amine linkage, amide linkage essentially. So that's gonna be C. Why is cryolite used? This is a really simple concept. You need to know that cryolite has 3 functions. It dissolves aluminum oxide, it decreases the melting point of aluminum oxide, and it also increases the electrical conductivity of aluminum oxide. So we can see that directly it's going to be A. Also, it cannot be D because this is aluminium, not aluminum oxide. Methane reacts with chlorine in a substitution reaction. How many different products can be made? So this is a tricky question. Over here, you need to keep in mind the reaction that actually occurs, which is CH4 plus Cl2, which can form CH3Cl plus HCl. And in the presence of UV light, this is how the reaction occurs. So if I were to draw the whole thing in like a diagram nature. Okay, so over here we can see that chlorine can either swap with one hydrogen to form CH3Cl, and the other remaining chlorine actually goes on to react with the hydrogen that it swapped with to form HCl. The next thing that we can see is once we have the CH3Cl, this is again vulnerable to UV light substitution reaction, where another Cl molecule can substitute hydrogen, forming the CH2Cl bond, and this just keeps on repeating until we can have 4 different kinds of products. So we're going to have C as the answer.